This is the next video in the chapter on stoichiometry of chemical reactions. In the first set of lectures, we talked about the first type of chemical reaction, which was precipitation. And now we'll move on to the second type, which is acid-base reactions. So we gave a short definition for these in the introduction, but we'll repeat it again here. So in an acid-base reaction, H plus is transferred from one substance to another. And this is likely a class of reactions that you're very familiar with. We come into contact with acids and bases all the time in our everyday life. So this H plus has another name. Since it only has one proton and no neutrons or electrons, we often just call it a proton. The substance that is giving that proton, we call the acid. And the substance that is receiving that proton, we call the base. More on those in a minute. And make sure we put in some real life examples of where you've seen these before. All sorts of household products and foods that we eat are acids and bases. Here's one example. If you have ever taken an antacid for heartburn, the antacid neutralizing your stomach acid is an example of an acid-base reaction, with the antacid being the base. Another example is acid rain. When acid rain starts to dissolve marble or statues that live outside, this is an example of an acid-base reaction. So what actually is an acid and what is a base? There are several different examples, each more inclusive than the last, but this is just a preview. So we are going to use the Arrhenius definition, which is the simplest and most straightforward definition. And you will learn more about the other definitions at a later time. So the simplest definition of an acid is that an Arrhenius acid produces H3O+, which we call hydronium, when it is placed in water. So to know if one of the reactants is an acid, you're looking at the products that are formed. So this is one of the polyatomic ions that we know from earlier, but you should know that sometimes instead of writing H3O+, sometimes it's easier to just write H+, because an H3O+ is just a water with an extra H. So you may see it written as this instead. So here's an example of an acid, HCl, which is called hydrochloric acid. When you place that acid in water, that acid produces H3O+. It gives that proton to the water to make H3O+, and then that chloride is left over in the solution. So if an H3O+ is in the products, then the reactant that gave the proton is the acid. So we'll move on to the Arrhenius definition of a base, which is the simplest one, but it'll work for our purposes of introduction. A base produces hydroxide in water. So here's an example of one we've already seen before because we've already talked about hydroxides as ionic compounds. When sodium hydroxide is placed in water, indicated by the aqueous symbol, it dissociates into that sodium cation and the hydroxide polyatomic anion. So when we see that the hydroxide is produced as a product, that means that the reactant that gave us that hydroxide is the base. So we've sort of divided the important compounds into two categories, acids and bases, and each of those two compounds has different strengths of acid and different strengths of bases. So strong acids and strong bases have a particular quality that makes them unique. If we call something strong, that means that it dissociates completely in solution. And you may be saying, what do you mean it dissociates? Exactly what we drew up here. So when the HCl split up into that proton that was given to the water and the chloride, or when the base dissociated into that sodium cation and the hydroxide anion, that is the dissociation process. And for strong acids and bases, every molecule that goes into solution does this process. And we care so much about these compounds that we actually have a list of them. And this is a list that I'm going to ask you to memorize. In order to speak the language of chemistry, you need to know how to write the formula for these compounds, the name of the compounds, and to be able to identify them as strong acids or strong bases. So there are 6 strong acids. You'll want to write these down in your notes. So we have HClO4 perchloric acid, HCl hydrochloric acid, HBr hydrobromic acid, HI hydroiodic acid, HNO3 nitric acid, and H2SO4 sulfuric acid. So these guys up here, these 3 are called binary acids because they only have 2 atoms, one from the halogen group and 1 proton. And then these other 3, these are called oxyacids. As you can see that they have oxygen as well as another nonmetal and hydrogen. And so you may notice that the names of these oxyacids involve the name of the polyatomic ion. So this is sulfate, so we have sulfuric acid, this is nitrate, we have nitric acid, and this is perchlorate, so we have perchloric acid. And then you will need to memorize these 6 strong bases as well. But these are much easier because they're actually just binary ionic or simple ionic compounds like we've already learned to name. We have LaOH lithium hydroxide, NaOH sodium hydroxide, KOH potassium hydroxide. We have calcium with 2 hydroxide groups, which is calcium hydroxide, strontium hydroxide, and barium hydroxide. And these are exactly the sorts of compounds we already know how to name. These first 3 are bases made out of group 1 metals, and the bottom 3 are bases made out of group 2 metals. So it's important to be able to recognize and name these when we move on to acids and bases more in the future, so we can distinguish between something that fully dissociates and something that does not. So, of course, if there is something strong, there is something weak to complement it. So we also have things that are called weak acids and bases. We are not going to memorize that list because there are many, many of them. The way you can identify a weak base is if it isn't on the list of strong acids and bases, then it must be a weak acid or base. So these weak compounds do not dissociate completely. They dissociate to a small amount. It depends on the acid or base. Usually it's less than 10%. So you could say about 10% of the molecules of a weak base would produce hydroxide in solution, and the rest of them, the other 90%, would just remain as that ion in solution. We've just learned about acid and base reactions, and now we're going to look at what happens when you put an acid and a base together, which is called neutralization. So neutralization is one specific type of acid-base reactions. There are others, but you will cover those at a later time when you spend a full 2 weeks talking about acids and bases. For now, neutralization. So in a neutralization reaction, we combine a strong acid and a strong base together. And the products that are formed by this reaction are always the same. They're always water and a salt. This is probably something you've seen before. And remember that salt is a word that we use to refer colloquially to an ionic compound, which we know about. So here's an example of a neutralization reaction. So we can take any of our strong bases and our strong acid. So here's a strong acid, hydrochloric acid, and here's a strong base, sodium hydroxide. When we combine them together, we will remember to label what we're doing. There we go. So what we do is, to form the water, we take the H away from the acid and the OH away from the base to form H2O, which is a liquid. And then with our remaining anion from the acid and cation from the base, those two form an ionic compound, salts. And sodium chloride is aqueous. It's soluble in water. So the main tasks that you need to be able to do with acid-base reactions at this time is to predict the products when a strong acid or a strong base is dissolved in water, and to be able to predict what happens from a particular neutralization reaction. So let's do an example of each. So predict the products formed when nitric acid is dissolved in water. So we have memorized the strong acids, so we know that the formula for nitric acid is HNO3. It is dissolved in water, so we'll put that here. And then we need to predict the product. And so the definition of a strong acid is when it is placed in water, the acid gives its H plus to the water to form an H3O plus. And then the other half, the anion half of the acid, is left. So we'll have a nitrate ion dissolved in solution at the end. So these are the products that would be formed from that dissolution. Let's try the next one. Predict the products formed when nitric acid is used to neutralize aqueous calcium hydroxide. I'm going to focus in on that word neutralize. That tells me I'm going to need to do a neutralization reaction, which is always strong acid plus strong base forms water and salt. So strong acid, that's my nitric acid. It has the word acid in the name. Strong base is anything with a hydroxide in it, calcium hydroxide. And I know the polyatomic ion hydroxide is an OH. Make sure you check if you didn't memorize the formula so that this is balanced. Hydroxide has a -1 charge and calcium has a charge of +2. So there are going to need to be 2 hydroxide groups in this base. And then when I need to predict the products, I'm going to always predict water made out of an H from an acid and an OH minus from my base. And then I will take the cation from the base, calcium, and the anion from the acid, nitrate, and that is going to be soluble as well. There we are. And don't forget, even though this isn't a molecular equation, we still need to make sure that it is balanced. You can see that there are 2 hydroxide groups here, and there's only 1 OH that went into the water. And I also haven't made this compound correctly. So I can see that calcium is a +2 charge. Nitrate I know has a charge of -1, so I need to have 2 of those and calcium nitrate. But now I have 2 nitrates and only 1 nitrate on this side. So I need to make sure I put in a second nitrate here and a 2 in front of the water so that I have 2 protons and 2 hydroxides going to make that water, 2 nitrates, and 1 calcium going to make that product. So predicting the products, I predict 2 water molecules and 1 calcium nitrate. Make sure that you balance that at the end of your process. Those are the acid and base skills that you can expect to cover in this course. We'll move on to the next type of reaction class, which is redox.